Okay, so let's pick it back up with talking about accessing arrays. So now we've got our array declared, initialized. Perhaps we've used an initializer list to fill it up with elements. If not, we might need to use an array to fill it up with elements. So for loops are great for working with arrays. The typical structure of a for loop, if you want to access all elements of an array, are that you start at position 0 and you have your counter go, well, it is less than the array.length. This is very important, right? We do not want this to be less than or equal to nums.length, because that would mean we'd be trying to access the element at position length, and we know that there is no position at element length. So we want the counter only to go up to, but not including, the element at nums.length. Another way we could write this would be I less than or equal to nums.length minus 1. That would work as well. But this is the most typical way that you'll see a for loop written to go over an entire array, index starting at position 0, going less than the array.length, and incrementing each time. So this loop here is an example of using a for loop to fill up the array. So here at each index, we are filling the array with the value of that index times 5. So our array is going to hold 0, 5, 10, 15, 20. I think that array was, or it's 10 elements long, sorry. So it'll, etc. It'll hold those values. Okay, 0, 5, 10, and so on. So for loops are great for filling up arrays. For loops are also great for retrieving elements from an array. So again, here we have the same structure for the for loop, and then we just print out the element at each index. So we can access that element by putting the index number inside the square brackets. Because we're using a loop here, the index number is going to be I, and that allows us to either fill over the entire array or access over the entire array. And we can also use a for loop to modify elements. So here we, again, same structure for our for loop, but here we have an if statement saying if the index has a certain property, then let's change the value stored at that, or the array at that index. So what we're saying here is if I mod 2 is 0, this means that I is even. If you aren't sure how to use modulus or how to use it in particular to check for even or odd, post that question to the discussion board. You should be able to use modulus generally, but one very common way to use modulus is to determine parity, so to determine evenness or oddness. Make sure you understand how to do that, and if not, post a question. So here we're saying if that index is even, we're going to take the value at that index and we're going to multiply it by 2. Basically, we're going to double it. So the value at 0 is still going to be 0. The value at position 1 will be unchanged because 1 is not even. The value at position 2 used to be 10. Now it'll be 20. Okay, etc. So these are kind of just some simple examples of using a for loop to initialize or fill up the array, retrieve elements from the array and do something with them, in this case just print them, or modify elements in the array, maybe only certain elements within the array. And again, for loops are great for doing things like this. Now, whenever we're using for loops, we always, or arrays at all, for anything, I know I'm sounding like I'm repeating myself, but it's very important. We just want to be really careful about those bounds. So if you try to access something at position length or position n, you will get an array index out of bounds exception, and this is a really terrible error. One of the reasons this is such a terrible error is because it's entirely 100% preventable. We as programmers can be careful never to have this error be thrown and never to have our program crash for this reason. So we need to do that, okay? Running a program that throws this error, it just shows really sloppy programming is basically what it shows, okay? So this error is entirely preventable, so we want to avoid it. And when we're dealing with arrays, that again means we want to go up to length minus 1. We never want to access the element that at position length or position n. It is unfortunately easy to make these mistakes, and as I say, it's a sign of sloppy programming, but it's one that happens, and we see it. So just be really cognizant of avoiding it. Again, if in a for loop, for example, we do not want to go less than or equal to the size of the array. We'd want to just go less than the size of the array, or less than or equal to the size of the array minus 1. A somewhat newer addition to Java is the enhanced for loop, or sometimes called the for each loop. This is a really great way to use to work with arrays, and some of you might not have seen it before. As I said, it's somewhat new, relatively speaking, to the Java language. It's just another kind of loop. So what the for each loop allows you to do is it allows you to access each element of the array, and kind of it gives it a temporary variable name for you to do something with that element. There are some things you cannot use a for each loop for. So you cannot use a for each loop if you only want to do something to some elements of the array. So back here, and you want that selection of which elements to be based on the index. So back here in this example where we are doubling only the elements at even indices, we could not use a for each loop to do this. Okay, we just can't do it. The other thing we can't do is we can't access, again, the index of that element. So if you just wanted to print out the index, like this is the element at position 1, for each loop doesn't let you do that. So if you want to do something to only some elements at the array, and that selection is going to be based on their index, where they're located in the array, or you want to actually access the index of that array, use a good old normal for loop. But if what you want to do is not one of these things, then you have the choice. You can either use the for loop or you can use the enhanced for loop, also called the for each loop. So this is what the syntax looks like. It starts with your keyword for, just like a regular for loop. And then you put the underlying type stored in the array, and you put a temporary variable name. So this is just, you make it up, it's a variable name. Then you have a colon, and then you have the array name. And then inside you have your brackets, and inside your loop goes whatever you want to do with each element of the array. So the way we read this is we say, for example, for each int in scores, or for each course in a catalog. Okay, so that's why it's sometimes called a for each loop, because the way it's read is that you're doing something for each value that's of this type. Okay. So here's some examples. So this first example is that one we previously saw with a regular old for loop where we're just iterating over the whole array and filling it up. And this one here is where we are printing out, using a regular for loop to print out each element of the array. And here's an example of using the for each loop to do the same thing. So this for loop and this enhanced for loop are equivalent. What this for each loop does is it says for each integer in the array called nums, I'm going to temporarily call it each num, and then I can use each num inside my statement to do whatever I want to do with it, right? So in this case, I'm just printing out each num. The for each loop, it's basically as if you had a for loop, and then there's a line inside there that declares a temporary local variable and initializes it to that element of the array. So it's as if you had a for loop followed by int each num equals nums at I, and then you can use that local variable each num. So it's just kind of like a little shortcut. It allows you to, it automatically assigns a variable name to each element of the array, and that can be kind of nice to access those elements. So it's kind of nice to be able to read, oh, system.out.println each num, rather than this way. I don't know, some people find this easier to both write and to read if you're reading someone else's code. Totally up to you which you prefer to use. Again, as long as it's not one of those situations where you can't use an enhanced for loop. If you can use it, then you're welcome to use it. You can also just use a regular for loop. It's totally a subjective decision. The one thing I would say is to try to maintain some consistency. So if you want to use the enhanced for loop, try to use it consistently throughout a single program. Try not to switch back and forth, because in general, we just want to try to be consistent with our programs. Okay, so I want to back up. We talked a little bit earlier about the size of an array, and I had said that you cannot make an array bigger. And that is true. You cannot change the length of an array once you've specified it when you initialize that array. But let's say you need your array to store more things. Well, you can do that. What you have to do is you have to create a new array that's bigger, and then you have to make your array reference point to it. And you need to manually copy over all of that data. Okay, so this kind of makes it seem like you can make an array bigger, but you technically can't. This is just sort of, this is the way we do it in Java. If you need to store more things in an array, can't make the array bigger, but you can declare a new array that's bigger, copy all the elements over, and then make your array reference point to it. So let's say we had an array that held 3 integers. We can use an initializer list here to say it's going to hold the numbers 1, 2, and 3. And now let's say we actually realize, oh, we actually need to store 5 integers. Well, shoot, what am I going to do? I can't store more than 3 integers in nums because I've already initialized this array to be of size 3. So what I can do is I can create a bigger array. This is going to be my more nums array, and it's going to hold 5 integers. This is a bigger array. It's empty. What I need to do now is I need to copy manually all the elements over from the original array, nums, into the new array, more nums. So I have a for loop. That for loop is iterating over the size of nums, right? Because I only have 3 elements. Those extra 2 spaces right now in the new array, the new bigger array, they're not filled. I don't have values in them yet. So I iterate over the size of nums, and I take each value at that index and I put it in the new array. And then I say, okay, now I'm just going to take my variable name and I'm going to assign it to what's stored at more nums. Well, what's stored at more nums is a memory address, and so now nums and more nums point to that same newer, bigger array in memory. Okay, and more nums, I'm sorry, the original array that held 1, 2, 3, that shorter array, there's now nothing pointing to it, so it will eventually be garbage collected. Okay, so let's look at another example here. Here we have a nums1 array that holds 1, 2, 3, 4, 5. And now we say int array nums2 points to it gets the value of nums1. So let's just stop right there and look at what happens in memory at that point. So we have our array, I call them nums1. And it's an object, so it points to somewhere in memory where we hold 1, 2, 3, 4, 5. An array with 5 elements. Okay? That's this first line of code. The second line of code, we're saying we're declaring an array called nums2, and we're giving it the value of nums1. So here we have nums2. And what is the value of nums1? Well, because it's an object, that value is a memory address. So when we say nums2 gets nums1, nums2 gets that same memory address. So that means that nums1 and nums2 are now aliases. That means they are 2 references that point to the exact same place in memory. This is what happens when we use the equal sign with objects. And remember, because arrays are objects, it's going to happen when we use it with an array. Okay? So now when we change the value at position 0 of nums2 to 99, this is the 0 index of nums2. So it's going to be changed for both nums1 and nums2 because, again, they're aliases of each other. Okay, so nums1 and nums2 are aliases. If I make a change to one, I make a change to the other. Okay, so if I didn't want to do that, if I just wanted to create 2 separate arrays, but I wanted to copy them over, I can't just use assignment to do that. If I use assignment, I'm just creating aliases. I still only have one array, but now I have 2 references that point to it. If I wanted to have a whole separate array that stored those same values, I'd have to use a loop like this to copy over from one to the other. So if I used a loop like that, what that would look like in memory is if I had nums1, oh, that's a particularly bad writing right there. Sorry. Okay, if I have nums1, and then I have nums2, again, if I just use assignment, I'm going to create aliases. But if instead I created a new array and then I used a for loop to say nums2 at 0 gets nums1 at 0, nums2 at 1 gets nums1 at 1, nums2 at 2 gets nums1 at 2, etc., and I copy over all the elements individually, now I have 2 copies of the array. And now if I go up here and change this to 99, just affects one of the arrays. Okay, so you got to be really, really careful about using assignment like this with arrays because it's probably not going to give you the behavior you want. I'd say it's very rare that you want to create an alias of 2 arrays. It's much more common that you're intending to create a copy of the array, but this isn't the way to do it. So if you want to create a copy of the array, whether it's to create a new array that can hold more things, or whether you just need a copy for a second purpose, you have to use a for loop and copy those elements over individually. Make sure you understand that idea about copying arrays, and if you don't, then post that to the discussion board, okay? Okay, so related to this idea that we've been talking about is the idea about passing arrays as parameters. So again, arrays are objects. What that means is that in memory, what's stored at their place in memory is a reference to somewhere else where that array lives. So what that means is when you pass an array to a method, what gets passed is the value of that array variable, but that value is a memory location, and that means that the formal and the actual parameters are aliases. So if you have a reference to the array in the first method, you then pass it as a parameter to the second method, there's only one array. You just now have two variables that are pointing to that same array, one in the original method and one in the second method. If you make a change to an array in that second method, it's going to affect the array in the first method because it's the same array. Okay, this is true of any object. And because an array is an object, it's true of arrays as well. So we're going to look at an example of this in the practice. So hold on for the next video to make sure this makes sense when we take a look at the example. And if it doesn't, post that question. So I'm going to stop this video here, and then the next video we'll be going through a couple of these practice exercises, and we'll go through all of them because I'd like you to try some on your own and then post questions to the discussion board.